viewers, it's Lekajit here, and this video is for those students who are going to who are going to appear BSc first time exam mechanics paper tomorrow. So today I'm not going to teach anything here. Just I had a comment. I had got a comment that from at the red backbenchers of Assam 3719. I don't know what is the good name of this person, this ID holder. Please let me know your name if you want. Okay, so now you see, just I try to pick some important topics, but you know, don't take it for granted. Okay, because if you are a student of BSc, so you should study each and every topic, and you should have clear concept on each and every concept, each and every topic of your syllabus. But though I have got the comment, so I have tried to pick some topics, important topics. Just I have analyzed the paper. Then there are few topics, questions, each and every semester. Questions, at least one questions from these topics used to come, right? So there are few topics that may give you 10 to 15 marks in the exam. Okay, and okay, now let me take you to the screen of my device, and before that, please subscribe the channel if you are new to my channel, and hit the bell icon so that when new video will be uploaded, you get notified. And also you may send me question papers. If you have previous year question papers that you can, if you cannot solve, then you can send me. Okay, only physics papers, right? So if you want to send me question papers, so ask for my ID in the comment box. So I will provide the ID. You can send a PDF. Okay, so now you see, let me take you to the screen of my device so that I can show you the topics, which are important topics. But still I would like to suggest, but I would like to suggest that you should study all the topics, right? So let's go. So the most common topics of your mechanics paper is Kepler's law. It's in every semester. At least one question is asked from this topic, Kepler's law. Okay, so all the three laws and their proof, very important. And then next important topic is your, you know, moment of inertia. Moment of inertia of rectangular lemma. About different axes. Number one, suppose it may be asked about axis in its own, and passing through and one end, passing through an end, you can say like this. So number two, axis, about an axis perpendicular to the plane. Okay, then similarly you may ask to find the moment of inertia of circular ring, and circular discs as well. About different axes, maybe about tangent to the circular ring. Number two, about the diameter Okay, and about an axis perpendicular to the circle, perpendicular to the circle or ring through center, through the center. Okay, so study all those topics. Then moment of inertia of solid cylinder, about different axes, about geometrical axis, about the geometrical axis. That means suppose this is the cylinder. So if you are calculating the moment of inertia about this axis, right, along its height or length, then it will be called geometrical axis, about the geometrical axis. And next you may ask to find the moment of inertia of the solid cylinder through the center perpendicular to the geometrical axis. That means through the center perpendicular to the geometrical axis. Axis through the center perpendicular to geometrical axis. Right. Then next you study this moment of inertia of spherical cell with thick walls. Spherical cell, or you may ask to find a moment of inertia of spherical cell with thick walls, and moment of inertia of solid sphere as well. About different axes, about diameter, and maybe about tangent. Right. So now you see, so moment of inertia is one topic, and from this chapter one question may be asked, maybe it may be 4 marks, 5 marks. Okay, so to get that 4 and 5 marks you have to study these subtopics, because you don't know from which one the question will be asked, right? So you may ask to calculate the moment of inertia of spherical cell, moment of inertia of rectangular lemma, cylinder, solid cylinder, or circular ring, discs. Okay, we don't know which one will be asked. And also you may ask to solve numerical problems related to this topic. So numerical problems related to this topic or based on these topics. Okay, so practice all the numerical problems given in the book that is being used by you, right? So there must be some examples given in the books, right, textbook that you are using. So practice those problems from on this based on these topics, moment of inertia. And our next important topic is uh, gravitational potential. Gravitational potential. Gravitational potential due to a spherical cell. Due due to a spherical shell or maybe a solid sphere. Due to a solid sphere, both may be asked. Okay, so there will be three cases. One is small r greater than r. That means if the gravitational potential at a point at a distance r, which is greater than the radius of the sphere or shell. Okay, that means the point lying outside the sphere. So this small r may be given in the question as small a. In some author use small a rather using small r, so don't be confused. Then when r is equal to capital R, that means when at a point on the surface, this is another case. Then r less than capital R, that is if the at a point inside the sphere or cell. So one of out of those three, one case may be asked. Okay, so that's important. So one questions may ask from this topic as well. Then let me tell you the next topics. So relation between the elastic constant, right? Relation between the elastic constant. Elastic constants. So using this relation, question may be asked in the question paper. Numerical problems may be given using this relation between the elastic constants. Then next topic is twisting torque on cylinder or wire, right? Or wire. Then Poiseuille's equation. Next topic is Poiseuille's equation. So these are very important topics. Okay, so numerical problems may be asked. So these are the important topics. Okay, so study thoroughly, but don't miss these topics. Okay, don't miss these topics. And if you have studied thoroughly, if you have covered all the syllabus, then that's gonna be better for you. So thank you for watching and stay connected. See you in the next video. Best of luck.